Hello everybody and welcome to my channel. With WWDC behind us, I was reminded of a topic that I wrote about almost 7 years ago. Funny enough, it was not even a new thing that was announced with shiny letters at the keynote. No, it was something that was coming through Swift evolution for a while, hence I already knew about it. But, WWDC had to happen for my light bulb to turn on. I'm of course talking about macros, a new and very powerful Swift feature that allows us to write code that is executed at compile time, and it lets us add automatically new code programmatically into our program. This is of course very powerful for a number of reasons. We have even seen at WWDC how the new Observable API that relates to Swift UI is based on it. Behind the scenes, it uses macros in order to generate the boilerplate needed to make things observable. And instead of having that directly in the compiler, it's just a library that offers these capabilities. We've also seen how the new Predicate API offers compile time and type safe query like syntax. So we don't have to use the old string based NS predicate anymore. It's actually checked on compile time, super type safe, you cannot mess up, and it's very expressive. All of that also uses macros under the hood. But of course, unfortunately, there is always the people that likes to complain, and there is a backslash about new things added to the language, making the language more complicated, which is pretty weird in this case, because what macros allow is giving us a new tool to actually simplify things, to make things that were too complex, that require too much boilerplate, or even things that were impossible unless you went and changed things in the compiler. Now plenty of this stuff, it's actually possible to do at a library level, reduce boilerplate, which means that newcomers or experts are gonna have way simpler times using more powerful features. Just look at Observable, for example. You don't have to know about the protocol, you don't have to know about the add publish property wrappers, you cannot forget to do one thing or the other, you just add the annotation and that's it. It works out of the box.
But some APIs can be hard to use, requiring you to write a lot of boilerplate code just to get started. That's why Swift is unlocking a new kind of API that's easier to use and easier to get right with the introduction of macros. And these macros are done the Swift way.
So today I'm here to talk about a usage of this macro system for something that I wrote many years ago. I used a specific problem, very common in UNKit back in the day, which was about avoiding the keyboard. I used that example to talk about the capabilities of the new language in terms of protocols. I want to talk about what I usually call trains and mixins, which in basic terms, the most simple of the protocols is just an interface. It defines a contract that you adhere to, but of course, we all know the protocols are way more powerful than that, especially in Swift, because Swift allows you to extend that protocol and add methods to it, add functionality. So we have a way of specifying functions that where the type conforms to that protocol, it gets for free. And this is what I usually call a trait, at least in this context. But we're still having a missing piece of the puzzle, which is what I usually call a mixing. If a protocol with functionality, I usually call it a trait, the next step on the puzzle is actually let that protocol add storage. And of course, that's not very common in most languages. Not all languages have it. Usually languages that are more dynamic and runtime aware, like they don't have a compiler, for example, they just run things in an interpreted mode. Those kind of languages, it's very easy to add this kind of functionality. But in Swift and the kind of languages that I'm interested in, it's tricky because at the end of the day, your code gets compiled into a machine code and the memory layout is very important, even if we don't think about it on our day to day. But it's something that needs to be considered for the language. So back in the day, what I did was just hack it around with Objective-C runtime. But the problem is that we shouldn't have to rely on the Objective-C runtime and those kind of hacks to do things in Swift. So I'm happy that finally, after so many years, Swift has a way of solving this problem. So what used to be kind of a hack using Objective-C, and otherwise it was impossible to do in a pure Swift code base, nowadays, thanks to macros from Swift 5.9, we're able to do it in a different way. So for example, I have here just an example of a view controller that has a scroll view. You know, from somewhere, that doesn't matter. Storyboard, a lazy property that you create, it really doesn't matter. But then, instead of conforming to a keyboard avoidance protocol like we had to do in Objective-C, we annotate the view controller with this keyboard avoidance macro. So with this annotation added, the macro is taking care of generating the necessary code for us. Now the only thing you need to do is hook into the lifecycle of the view controller and call the methods that are now available. And please don't focus on the specifics of keyboard avoidance because I'm just taking a 7-year-old example to talk about macros. Even at WWDC, they talk about new APIs to do properly keyboard avoidance. So please make sure you watch that and don't take this as an example, please. So how does this solve the problems that we used to have? And does it in pure Swift? Let's take a look at the macro itself. The module that you import is a module that it basically offers a protocol, which as you can see is the same as before. That hasn't changed much. And as we're able to do before, this protocol offers you a way to include functionality. Nothing new there. But as you can see, this protocol defines two pieces of storage, two properties that it needs to actually work. Now let's take a look at how the macro allows us to get those pieces of storage for free. The key here is that the protocol is also a macro, and it's pretty cool that we can use the same name and it actually works very well. So what we do here is tell the compiler that this macro is defined as a separate program, because that's actually how macros work in Swift. They are separate Swift package plugins that the compiler is able to run at compile time. But they are not part of your code. They live as a separate project and package, which helps the compiler ensure safety and performance. Now we define this macro to have two powers, two behaviors. One is the ability to add a conformance to the protocol. And as we can see, that's what we do because we are now conforming to the protocol and thus we get access to the extra functions and functionality. The other thing we can do is add members into the type where the macro is attached. To add these members, we just need to define their names and that's it. The compiler will include those new properties or methods or functions or whatever you want, but the new thing here is that it works for properties and thus the compiler will add that storage at compile time to that type as if you wrote it yourself. And the most amazing thing is that you can actually go to Xcode and say expand this macro and you actually see the macro expansion happening in line. So you can actually read the code that the compiler is generating for you. That's super helpful because you can even put a breakpoint in there and Xcode is gonna stop inside the macro, but it's fully transparent as if it was your code. Now I'm sure there is better ways of writing this, maybe we don't even need the protocol anymore. It's just an example to show how things that we couldn't do before, now they are very possible. But is this enough to say that we have mixins in Swift, that we can add storage to types? I would say not yet, because right now we have written a specific macro that in an ad hoc way adds the specific properties that we need. But ideally, we would want to have a way to pass a protocol to the macro and for the macro to read what that protocol needs and add the storage that it needs. And as of today, I'm not sure that's possible because macros are very specifically implemented nowadays to just have access to the types they are attached to and a bit of the surrounding context, but that's it. You cannot use a macro and receive, the string of a protocol and actually tell the compiler, give me all the information that you have about this type. That's not there yet. Hopefully someday it is, and we will be able to write a generic macro that allows us to add all the storage required for a protocol. So in terms of macros, that's a limitation that hopefully someday goes away. But there is another thing to discuss here, which is the limitation about the behavior. We are able to call these methods and get them for free and now get the storage. But we still need to hook into the view control lifecycle and call those methods manually. And I'm not sure there is a solution for that. Yes, the macro could generate the view did load overrides and do it itself. That's fine. But as soon as you want to customize that, then you lose what the macro did for you. Or you do it yourself, or you let the macro do it. There is no middle ground really. This is the concept of behavior-driven development. Call it whatever you want. It's been 10 years. I don't remember how we used to call that topic back in the day. But the idea was that there was a behavior system where you can attach behaviors, components, like in game development, and the system use the proper life cycles to call your components. So we could say we still don't have a solution for that. Maybe we're going in that direction, but we're not there yet. But the thing is that I haven't think about mixins and about this behavior system for many years. And I'm not sure if all of this is actually needed anymore. It's like, yes, I think it's good that we have solutions for it, and I think it's good that the language is evolving to allow all of this. But maybe it's not needed because we have moved from a very object-oriented model of making applications to a more functional approach. Things like Swift UI and even the DC architecture has moved us away from that OP-centric model where subclasses and life cycles were a big issue. In those models, these solutions were actually very appealing. But nowadays, our mindset is totally different. We use Swift UI where you can actually write a modifier, and that modifier, it's just like the entire view. It's like the view that you're writing yourself. There is no difference between them. You have all the power in a modifier, which involves adding a state. And this is very powerful. Maybe we have grown used to it already, but if we compare it with the status quo in UIKit, in an object-oriented system, it's night and day. We're able to create a modifier and attach any behavior that you want and any state that you want. And the system, it's not going to treat them any differently than if it was the main view. Your main view controller had very special powers, and it was very tricky to actually make a component system that hooked into them. So even if I don't think we need these mixins and adding a state to types anymore for UI development, I still think they are very useful in other scenarios, and I'm very, very happy that new functionality to Swift is allowing us to create the solutions ourselves. And as Apple has proven with the new frameworks and new functionalities, macros are very powerful to simplify things for the end user, for the developer, which is what we actually care about. So thank you for watching and letting me go through these memory roads where I explored a bunch of things from the past that I haven't thought about it for many years and recontextualize them for the new world that we live in now, thanks to Swift.9. See you all next time.